So hopefully the question number 9 you finish, because this one question they will give you one of the physical quantity. We don't know what is that. They don't have the name, but we know the unit. Okay, let's see the unit. The unit is a kilogram per second. Okay, so from here we see the info first. Okay, first one, the mass of the rocket is 50 kilograms. Launch vertically. Okay, go out vertically. The fuel is being burned, so the fuel is come out from the backside. The rate is a 2 kg per second. So that means they will come out burn rate 1 second, they come out 2 kilogram, okay, of the gases. So this one has a meaning. 1 second, they come out 2 kg of the gases, okay, when they burn. Okay, after that, the exhaust gas is being forced to out. So this one is a gases, 2 kilogram of the gases will force to out for every 1 second. So from here, then tell you what is the velocity for the gases to come out. The velocity is 1,000. So from here, the question I want to ask, what is the initial acceleration? Okay, initial acceleration. Okay, some students, they don't know the formula because here is memang don't have formula lah. We can guess by using the unit. Okay, because you want to find the acceleration, ms negative 2. So from here, the equation they give you is a kilogram per second. Okay, follow the, you can using the method for guess about the unit. Okay, if you want to guess the unit, I just do the calculation like this. Okay, so I put here. Okay, I want to convert, become final answer is a ms negative 2. Okay, the problem is I got velocity only. Velocity is a ms negative 1, is it? So I want to change become negative 2. So I need to multiply another s negative 1. So I need to multiply s negative 1. So I will become s negative 2. Okay, so from here, and also I want to ignore the kilogram. Okay, ignore the kilogram. I just want ms negative 2. So from here, the simple one, because I got 50 kilogram, if I using the formula to do the calculation, then should be 2 kg s negative 1. Okay, I go to ignore the kg first. Okay, I divide by 50. Okay, then after that, I don't have kg already. So I left is a 0.04 s negative 1. Okay, still not yet the answer because we only s negative 1. Okay, then I want to create become acceleration. Okay, I want to create become acceleration, so I need to change the unit become ms negative 2. So I need to multiply. Multiply with the velocity, there's 1,000 ms negative 1. So when I just multiply, I get it 40. Okay, my unit will become m. Then the s negative 1 plus s negative 1 become s negative 2. So this one should be the final answer. I get the acceleration. So this one is based on the unit. Then I get the answer. Okay, another method is, okay, we go to understand the kilogram per second. Actually, what's the meaning? 1 second produce 2 kg of the gases. Okay, then after that, we go and think about the forces. Okay, forces launching and the forces exerted by the gas is equal. Okay, they just like the what we learned about the momentum, conservation of momentum, but now it's a conservation of the force. That means the force exerted by the gas go to output, same like the force for the rocket they want to launch to vertical. So from here, the F1 is a launch up, F2 is an exhaust gas. So from here, we can put the formula for the MA1 equal MA2. So M, the first one is for the rocket lah. The rocket they want to launch. This one is for the gases. Okay, so the rocket, the mass, we know there's a 50. Then the acceleration, we do know. Okay, there's an initial acceleration for the rocket. So from here, mass for the gases, we know there's a 2 kilograms. Okay, after that, per second. So from here, I take 50, then A1, I do know. Okay, this one I straightforward to take the T, it's a 2 multiplied to 1,000. So they become MA already. Okay, 2 kilogram, S negative 1 multiplied to 1,000. So there's a become MA. Okay, straightforward. The A is get from the 1,000. After that, because this one unit is a -1. So I multiply so they become MA, become force. Okay, gaseous force. So finally, how I find the A1, I just put in all the calculation, then I get it. 2,000 divided by 50. So the acceleration for the initial rocket, there's a 40 ms -2. So this one's question is don't have the fixed formula. Okay, they give you one of the thing you need to understand. 1 second produce 2 kg of the gases. Then you relate it to the final answer what they want. Okay, so this one is follow the principle, then we create the equation. So this one is by using the unit. So you need to create the final answer with the acceleration ms -2. Okay, so this one is a question 9. So after the question 9, so that means we finish all the example question for the impulse and also impulsive force. Okay, if don't have, then I need to go to the following. There's a apply the impulsive force for the car safety. Okay, that means that all the feeders in the car, there's a related to the inertia, some is related to the impulsive force. So we go and see this part. Then this one normally is come out from the essay lah. Okay, they just call you to create some of the safety for the car related with the impulse or impulsive force. Okay, so we're going to see the structure for the car. Okay, normally which one we need to relate it with the what we learn about the topics. Okay, headrest. Okay, we're talking about inertia. Okay, the next one should be the safety belt. Okay, safety belt, we also sometimes talking about impulsive force, inertia also can. Okay, after that, the impulsive force, normally we're talking is a airbag. Then number 3, impulsive force. Okay, that means the time taken is longer, then the impulsive force become reduced. Okay, another one is a camber zone. Okay, camber zone also talking about impulsive force. Okay, after that, okay, this only. So for when you want to answer the essay question, don't repeat the explanation. So that means when you're talking about the airbag, you're talking the time impact become longer, reduce impulsive force. So the next one, you don't bring the crumble zone in. When you bring the crumble zone in, mean your explanation is the same. Okay, when you same, them crash already. So we take another things. So from here, only the headrest, seat belt, crumble zone, and also airbag is related with the impulse and impulsive force, and also the inertia. Okay, the rest, shutter screen, the windscreen, front bumper, ABS brake system, side impact back. Okay, this one is no. Okay, this one is no. This one is a personal got the explanation. Okay, now we go and see for every part the explanation. Okay, got one thing later you need to change. I think here got a little bit problem. Okay, first one, I'm going to see the headrest. Headrest, normally we say reduce the inertia effect of the driver head, or you can say the neck. Okay, reduce the inertia. Okay, another one should be the seat belt. Later we see the seat belt, also talking about inertia. So you mention the seat belt, then the next round you don't mention about the headrest because the explanation should be the same. Okay, if I go to the airbag, airbag normally we say absorb the impact, increasing the amount of the time. Okay, increasing amount of the time. After that, impulsive force can be reduced. So that means the airbag that come out from the steering there, when it just come out, then the driver will be hit to the airbag first. Okay, when it hit to the airbag is a soft one. They will absorb. Okay, after that, they increase the time for impact. When it just increase the time for impact, remember the formula, F equal impulse. Okay, after that, over the time. When the time just longer, the impulsive force will become smaller. So this one is a function for the airbag. Okay, how about a windscreen? Okay, windscreen is a common sense. We're not related with the physics. Okay, this one is just protect the driver. Okay, this one windscreen is not same like the screen in your house one. They designed for the fracture into the round pieces. So that means when it just spoil, they never straightforward become the scattering. Shattering means become the small pieces to fall down. There's a stick together. After that, the round pieces is a big size. So you want to make the windscreen to come down, that means you need to hit it. Okay, you need to take something to hit it, then the windscreen will fall down. Okay, so this one is a safety lah. When suddenly the windscreen was broken, then they never straightforward hit to the driver. Okay, they will stick together at there first. Okay, unless you're using something hard material to hit the screen, then the screen will fall down. Okay, so this one windscreen you can using the personal explanation to put in. Okay, because they don't have any crash. Okay, crumble zone. Crumble zone, yes, related with the impulsive force. So that means the car, when it just crash, the in front is a soft material. We call it crumble zone. So they take some time to be shortened, the in front part. So from here, when it just compress during the accident, it can increase the amount of the time. Again, increase the amount of the time. Okay, to come to become complete to stop. So from here, they can reduce the impulsive force. So that means headrest and also crumble zone, the airbag and also the crumble zone is the same explanation. Okay, we mentioned airbag, so the next round we just ignore the crumble zone. Okay, maybe you take another one, headrest, inertia. Okay, bumper, front bumper or also the back bumper. Okay, this one they're talking about the absorb the shock. Okay, from the accident. Okay, they absorb the shock, but this one is never related with the, although they are a little bit like impulsive force got, memang got. Okay, but from here we never put in the impulsive force. It's straightforward talking, they absorb the shock. Okay, after that, this one, the bumper, they made by the steel, aluminium, plastic, or rubber. Okay, we never using the very hard material. Okay, the material, some they can take some time to be uh, complete compressed together one. So they say the steel, aluminium, plastic, and also rubber. Okay, and also prevent the rusting. So this one is a front bumper. Remember, you just answer the word absorb the shock, they can get the marks already. Okay, then after that, we go to the anti-lock system, ABS. Okay, now the car is all using the ABS already. So from here, you can say ABS brake system. So this was enable the car to quickly to stop. That means when you just brake, they quickly to stop. Then they will take some time but to stop. Then after that, they without causing the brake to lock. They never lock the brake. So this one we call ABS. They're also not related with the concept we learned before. They're only talking about ABS is without lock the brake. Then you can stop immediately. Okay, this one I want you to change. This one. Side impact bar. Okay, side impact bar. I think in your paper a little bit different. So you have to change this one. Okay. Side impact bar. Okay, we see the diagram first. Where's the side impact bar? Okay, this one we call side impact bar. That means the door inside. They got one of the steel bar, metal bar. Okay, so this one is important. They want to prevent injured of the passenger. Okay, although the outside the door material is a soft, this one memang want to soft because when it just hit, it takes some time to crumble. After that, make the time impact longer, reduce impulsive force. But inside, they got the bar. This one impact bar must be strong enough. Okay, now you're going to see why the impact bar need to stronger. Okay, use the strong material. Okay, for the inside part, just like the steel. Okay, enable the protect the driver or passenger when the side collisions. Okay, this one also just talking about the stronger material. They want to prevent the passenger when it's just the accident at the side collision. So after that, maybe the front door, the side door is okay, they could crumble, but inside must be very strong. So prevent the car when it just collision, they hit to the passenger. So this one is the side impact bar. Okay, and the last one is inertia. Okay, seatbelt, we're talking inertia. Okay, reduce the inertia effect, avoiding the driver to thrown forward when the car suddenly stop. Okay, emergency stop. So seatbelt can hold the passenger or driver to move more forward and come out from the screen. They can hold back the driver. Okay, so from here, if the question got 5 point, you need to answer the 5 point for the safety. So from here, you can give the point example. You can put to the first one. You're talking about seat belt. Your seat belt is inertial. Okay, number 2, you're talking about airbag. Okay, airbag already is a impulsive force. Okay, number 3, you can talking about ABS. Okay, ABS is another explanation. Okay, number 4, you can say windscreen. Okay, the windscreen. Okay, number 5, you can talking about the side impact bar. Okay, 5 times 2 already is a 10 marks. So don't be go to repeat the explanation. So from here, airbag, if you're talking airbag, then you're talking about the crumble zone. Sometimes you cannot think you only think about airbag and crumble zone. The rest you forget already. So it's no choice, then you just write. Repeat the explanation. You got no choice already. Better than you empty. So maybe the seat belt, you think about seat belt. Another one is a headrest. The rest you forget already. So just put. Maybe you explain you using the word don't be bulat exactly lah. Maybe the sentence you change a bit. Okay, but the point still there. You're talking inertia. Maybe you change about the sentence. This one inertia is related to what? Explanation add a bit something different. They will give you the marks. Okay, so this one is a skill how we go to answer the essay question. Better is don't repeat. If no choice, you repeat, but don't copy the sentence exactly the same. Okay, changes some of the words you want to put in. Okay, so this one is a safety by using the impulsive force and also the inertia. So this one I think not inside your paper. You just refer here for the essay question. There's a comparison. Okay, just you see the 2 diagram. Normally the question want to compare lah. Okay, the watermelon is dropped from the same height on the 2 different surface. So one of the surface there's a concrete floor. Okay, concrete. Another one they put the sponge. So from here they ask you compare the force acting on the watermelon. Okay, normally we answer by full sentence. Okay, I know some students they need to write B, the force at the A, okay, bigger than the B. Some will do like this. This one is too short because sometimes the scheme answer, they want full sentence. Although they are correct, but they say too short, not complete the sentence, so they want you to put the full one. So you how to start? You just copy from the question. The force acting on the watermelon for which one? For the diagram B or A. Then after that, okay, answer by full sentence. Okay, so from here I find it. The force acting on the watermelon in the diagram A is greater. Okay, greater than B also can. When you just write greater, also can. Larger, greater, bigger, also can. Okay, this one is called comparison question. Okay, number 2. Compare the change of momentum. Okay, change of momentum. So remember, force equal change of momentum, V minus U, then over the T. For this one situation, how about the change momentum? Because just now we're talking the force already. Okay, force for the A is a bigger. Then the time taken sure changes lah, because you fall on the 2 different of the floor. Okay, how about the changes of the momentum? So when you compare the 2 things, another one, the third physical quantity must be constant. Okay, you cannot say, oh, the impulse also increase. If you 3 things also compare, I cannot get the result. So 1 must be constant variable, then 2 we do the comparison. So from here, the change of momentum become constant in both diagram because the mass is the same. Then you fall down because of the free fall. So free fall, the velocity should be the same because your object is the same. Okay, so from here I find it, V should be the same. Inertial sure is a 0 because you are dropping. So from here, change of momentum in both diagram, there's equal. Okay, change of momentum, or you say impulse lah. Impulse for the both diagram watermelon is equal. Okay, then the last one, sure, compare the time law. Compare the time impact, add to the watermelon. So the time impact sure for the B is longer. Okay, because you're using the soft material. Soft material, that means that when it just go down, the spun will be compact first. After that, it go back to the original shape. So that means they take some time already. So from here, the time taken, you just copy from the question. Time compact, add to the watermelon in the diagram A, shorter. Okay, or you say B is longer. Okay, time impact in diagram A, shorter. After three comparison, sure is a relationship. Okay, now you see the next one. Okay, state the relationship between time impact in the collision and the force produced. Okay, so normally we mention about time first because the time affected the force. So from here we just mentioned when the time impact increase, excuse me, force produced reduce. Or you want to mention time impact inversely proportional with the force also can. Okay, so from here we just answer the shorter the time impact, the greater the force produced. Okay, or you want to mention about directly proportional or inversely proportional, you need to put full sentence. Don't just give inversely proportional. Then we don't know what is that. So better give the what inversely proportional to what. So if you don't want, you just write the full sentence lah. We mention the time first. Okay, time impact shorter, then they produce the bigger force. Okay, this one comparison for the SPM paper 2, structure A. They got two questions. Okay, so we go to first one. Okay, the diagram they show you already. 2 kg of the metal ball, they fall from the building with the velocity 5. Okay, after that, what is the changes of the momentum of the ball if they punches back 3? Okay, so that means sure is one opposite directions. Okay, they ask you change of momentum. So that means they ask about impulse. Okay, impulse, the formula is a m v minus u. Okay, remember, I don't want the answer got negative. I want the answer is positive. So we always take the v is a positive direction. So take the upper, when it just go up, positive. Okay, when it just come down, I take there's a negative. Okay, so I just put 2 kilogram, v is a 3, minus u is a negative 5. Okay, so the 3 will become plus because minus and minus they become plus. So 2, 3 plus 5. Okay, then the final answer is a 16. Okay, unit for impulse, kg, ms, negative 1. Or you want to write Newton second also can. Okay, you check your answer. So you must practice how to press your calculator. Okay, don't every time just copy the answer. Then after that, when exam, you do know how to start the calculations. Okay, now we go to number 2. The car, the mass is provided. Okay, moving with the velocity 15. So from here, mass is 3,500. Okay, u 15. Okay, collide with the concrete wall. Okay, if the time, collision time, 0.003. Okay, the impulse of the car. So the question never mentioned final velocity. So we assume they only got one velocity lah. Okay, no need to put the negative. Straightforward to apply. So the impulse, m is 3,500. Multiply the velocity 15. Okay, that's all. That's not related with the time for the impulse. So the final answer is a 5,200, 52,500 kg ms negative 1. Okay, so this one is an impulse. So the next question, they want to find the impulsive force. So impulsive force, you just take the impulse just now, you get it. Then you go to divide by the time taken. Okay, so the final answer you can put in standard form. You also can write full. Okay, up to you. So from here, standard form, because this one's number is quite big, quite longer. So I put standard form 1.75 times 10 power of 7. Okay, then the force is Newton. Okay, so this one question is not much harder lah. They only got formula impulse and also the impulsive force. That's all. Important you know the info. The question give you what info. Okay, then we go to number 3. Diagram show the bubble move with the velocity. Okay, 25. Okay, after being hit by the finger, the time of the impact between the finger and the marble. Okay, now you must be careful. What is this? 5 ms. What's a 5 ms? M is stand for milli. So it's a 5 millisecond. So if 5 milli I convert become second, there's a multiply 10 power of -3. Milli is a -3. So what is the impulsive force? So the question also only provide one velocity. So we just take one velocity lah. So from here, impulsive force. Okay, the mass. Okay, the question got provide any mass or not? Okay, yeah, here. Okay, diagram will show the mass. So the mass is a gram. I need to convert. Okay, convert become kilograms. Okay, velocity 25. Then I over time taken -3. Okay, so the final answer. Okay, final answer we go to ask about the Wen Xuan. Final answer. Tongjian, you get how many?
I guess 75.
75. So Wen Xuan, you go and press again your calculator. 15 -3. Okay, you change become the kilogram. Multiply 25. Then you divide by the 5 times 10 -3. So I can get the full number is exactly 75 Newton. Because some of the power, you must be careful. Okay, we do step by step. Don't straightforward press your calculator, all the thing, then you equal. You must put the bracket. After that, you equal first. After that, baru divide by the time. Because sometimes the calculator, they do know which one want to do first. Okay, we do step by step. Sometimes you not because of you don't understand the question, you understand, but the careless for the press the calculator. So like this, you lost the mark already. Okay, so I call you to practice. This one is a reason why you need to practice to press your calculator. Okay, Wen Xuan can get 75.
Yes, teacher.
Okay, then we go to number 4. Shuttlecock, the mass. Okay, we got mass 50 gram. Okay, move at the velocity 45. Okay, 45. Okay, Chong Wei hit after that shuttlecock and move with the velocity 15. So that means the first is 45. After I hit, final velocity is 15. Okay, then after that, can move at the velocity 15. So that means normally sure it's the opposite direction when it just hit. Okay, don't have the shuttlecock count in the same direction, then you hit also same direction, is it? So normally they punch back. The reason is a punch back. So from here, velocity, they give you what is the impulsive force experienced by the shuttlecock if the time collision is again ms. Okay, ms. So from here, when you just hit back, remember one should be negative. Okay, normally I just suggest you take the final is a positive direction. Okay, take the initial is a negative direction. Okay, so from here we can do the calculation. 50 gram convert become kg. Okay, then after that, final velocity minus and minus 45. Okay, minus and minus the 45. Okay, after divide by the time taken also got milli. So it's negative 3. Okay, so we need to find out what is the impulsive force. Okay, so the impulsive force, I'm going to ask about the Chen Yu.
200.
Okay, final answer 200 Newton. Okay, then we go to the last one, number 5. Hockey player, they use a hockey stick to hit the hockey ball, causing the ball to travel with the velocity. Okay, 30. Okay, if the mass of the hockey ball is 100 gram, okay, and the time impact between the hockey stick and the ball, time taken provided, 5 multiply negative 3 seconds. Calculate the impulsive force. Okay, it's the same thing. Okay, only one velocity for you. So we just take 100, you change kilograms, so 0.1. So the V is a 30. Then you divide by the time taken. Okay, negative 3. Then after that, finish. Okay, the force. Okay, we're going to ask about Yanyi.
600.
Yeah, correct. 600. Then don't forget the unit, Newton. Okay, so for the structure 5 question, I think there's a no problem. Or just apply the formula. And important, you understand the question. Okay, normally for the impulsive force, impulsive force, normally we just seldom to put the negative one because it's normally about the injured. Okay, if not injured, sure it's slow down. Okay, so opposite direction, you want to make it become positive. Remember the final direction, the final velocity. We take it as a positive direction. So that means the formula we follow V minus U. So your V minus and minus become plus already. Okay, so your final answer is no negative one. If got negative, then you just add one more sentence. Finally, the ball is moved in opposite direction. That's all. So you get negative.